In this video, we're going to go through an example of using the law of sines to figure out missing information in a triangle. So right now we're given the length of AB as 8 centimeters, we're given the length of BC as 7 centimeters, and we're given that the measure of angle C is 65 degrees. So we don't know the length of AC, which sometimes in here, because it's across from angle B, you might list it as B centimeters, just for use in the formulas we're going to do. We don't know the measure of angle B, and we don't know the measure of angle A. We do, however, have an opposite known side length and angle measure pair, which is going to allow us to use the law of sines. So we'll have the ratio defined, the ratio value defined for us. So let's begin by solving for the measure of angle A. So we know that one of the forms of the law of sines is going to tell us here that the sine of the measure of angle A divided by the side length opposite will be the same value as the sine of the measure of angle C divided by the side length C. And why I chose that one is that's the pair that we know. So let's put in some information. We don't know the sine of the measure of angle A. We do know its opposite side length, so 7 centimeters. Sine of 65 degrees, because measure of angle C is 65 degrees, and its opposite side length is 8 centimeters. And now we solve for the sine of the measure of angle A. So we'll begin by just multiplying by 7. So we get the sine of the measure of angle A will be 7 times the value of the ratio. So we use a calculator to figure out the sine of 65 degrees. So we check we're in degree mode. We will do 65, the sine of 65 degrees. We get 0.9063. So we need that value divided by 8. So that's going to tell us that this value in here is approximately 0.1133. And we'll multiply that by 7. So 0.793. So that's the sine of the measure of angle A, telling us that the measure of angle A is going to be the arc sine, or the inverse sine, of 0.793. So we've got that 0.793. We'll do the inverse sine of that value, 52.47 approximately. So when we come back over here to our triangle, we can insert the known information. The measure of angle A is about 52.47. Before we go any further, we don't have to use another law of sines or law of cosines to figure out the next piece of information, because we're only missing one angle measure in the triangle, and we know that the interior angles in a triangle, that their measures all have to add up to 180 degrees. So in our calculator, we're going to go 180 degrees. We're going to subtract 52.47 degrees. We'll subtract 65, and whatever's left over has got to be the angle measure for the third angle. So 62.53. So now we know all 3 angle measures in the triangle. We know 2 of the side lengths. We're just missing this third side length, the value of B. So to find out this missing side length here, we're going to use again the law of sines, but this time let's use the reciprocal version that has the side lengths on top. It's a little easier to solve these equations when the unknown value's in the top of the ratio. So we know then that the value of B divided by the sine of the measure of angle B has got to have the same ratio as any of the other ratios. And we can use either one. We have the side length pair for angle A, we have the pair for angle C, but let's use the one given for C because we know this was given information. This value here, the measure of angle A, is rounded. So we'll be a little bit more precise if we use the given information. So we'll use the side length C divided by the sine of the measure of angle C. And we'll put in the information we know. So B divided by the sine of 62.53 degrees. So that was also rounded. So I'm going to put approximately equal to here. Anytime you've got a rounded value in your equation, it's good to put that so you acknowledge that you know this value is not exact. The length C is 8 centimeters. And the sine of the measure of angle C, 65 degrees. So then the value of B, we just multiply by the sine of 62.53 degrees. So times the value of that ratio. And now we have to evaluate. So we will do 65 degrees. We will take the sine of that value. So that's about 0.9063. 8 divided by 0.9063. So we get about 8.8271. Right, and we've got the sine of 62.53 degrees times that, and that's approximately equal to B. So then 62.53 degrees, the sine of that value, about 0.88725, we'll multiply that times 8.8271. $7.832. So the length of B, so B is approximately 7.832 centimeters. Now, just as kind of a check, if you remember from previous classes, geometry classes that you might have had, you should remember that the longest sides in a triangle are always across from the largest angle measures, and the shortest sides are always across from the smaller angle measures. So if we look here, we've got three angle measures we know, 65 degrees, 62.53 degrees, and 52.47 degrees. So the largest angle is 65 degrees. The side length across from that, 8 centimeters, is the longest of the three side lengths. 52.47 degrees is the smallest of our angle measures, and 7 centimeters is the smallest of our side lengths. So it checks out. This is always a good check to make sure you didn't do anything wrong. If this comes out to be right, it's a good indication that you probably have the correct values.